lesson is all about converting improper fractions to mixed numbers and mixed numbers back to improper fractions. And first I want to consider a situation where you need to make a large sheet cake and I need 5 cups of flour. Now, ask a friend Alice, and she responds that she has 1,200,300 over 250,000 cups of flour. Now, admittedly, this is a bit of a ridiculous scenario, and the number specifically in that fraction, both fractions, the numerator and denominator, are very large. But the point remains that if we were given a fraction like this, how could we tell whether or not Alice has enough flour to help make this large sheet cake that we need with 5 cups of flour? Go ahead, jot down a few thoughts that you have, pause the video, and come back when you're ready to move on. So, again, getting past the fact that these numbers are somewhat unrealistic, but they're designed to make a point, what could we do in order to determine whether or not Alice has enough flour? Well, we could take the number 5 and we could convert it to a fraction over 250,000. Now, over 250,000, 5's fraction would be 1,250,000. Over 250,000, we could determine that no, Alice does not, in fact, have enough flour for us to use to make a large sheet cake. Now, if we had some available, maybe that would change the scenario, but she does not have 5 cups of flour. The other thing we could try to do is to try to convert this fraction that I'm circling in red, try to convert that fraction to something a little more friendly so that we have some number either between 4 and 5, or in this case we know it's between 4 and 5 because we know that she actually doesn't have enough flour, but try to convert it to some sort of number that'll give us an indication. Does she have less than 5 cups of flour? Does she have more than 5 cups of flour? And to do that, we're going to look at a few different types of fractions. And so, go ahead and pause the video and write down these important vocabulary terms that we're going to use and need throughout the rest of this lesson and when we look at it in class. The definitions of a mixed number, a proper fraction, and an improper fraction. Go ahead, pause the video, write all 3 of these down, and come back when you're ready to move on. So, as a matter of review, because you should be relatively familiar with these concepts as it is, but as a matter of review, a proper fraction, we'll start in the middle, is a fraction which the numerator is less than the denominator. It's not less than or equal to, it is strictly less than the denominator. If that is not the case, and it's just a single fraction, it is called then an improper fraction, one in which the numerator is either greater than or equal to the denominator. And if we have a combination of whole numbers and fractional parts, we have what's called a mixed number. And a mixed number is generally only included when we have whole numbers and proper fractional parts. But it could include improper fractions if we need to convert it as such. So let's take a few examples of each of these different types of fractions and numbers so we can make sure we have an understanding of them. An example of a mixed number would be something like 2 and 1/3, a whole number underlined in yellow, and a fractional part underlined in black. Proper fractions are ones where the numerator, such as 7, is less than the denominator, such as 10, and an improper fraction could be things like 13/5, where the numerator is actually greater than the denominator, or one like 14/14, where numerator and denominator are equal. Go ahead, pause the video, and add 5 more examples to each of these 3 types of fractions. 5 mixed numbers, where it's a whole number combined with a proper, not an improper fraction, 5 proper fractions, and 5 improper fractions. So obviously there are an infinite number of potential ideas that you could have for these, so we're not going to go through any examples for this now, but the key point being that a mixed number has to have a whole number and a proper fractional part. This represents 2 and 1/3 more than 2. A proper fraction has numerator less than denominator, and an improper fraction has numerator greater than or equal to denominator. So let's go ahead and look at a concept that's or a problem that's a little bit easier to see than that first problem we worked with. Sheila is proudly exclaiming that she has almost 11/4 jars of coins in her house, 11/4 jars of coins. And so we want to represent that as a mixed number because a mixed number may be easier to understand in this case. So go ahead and think, how could we potentially represent this as a mixed number? Jot down some thoughts if you have any, and then come back and we'll go through that process. So for 11/4, we have to figure out a way of making 11/4 into a mixed number, which has a whole number and perhaps a fraction. Well, actually, definitely has a fraction because it's a mixed number. So the key thing here is that our denominator is fourths. So if we draw this as a picture, one whole jar of coins will have 1, 2, 3, 4 fourths in it. So now here we've got 4 fourths, and that is one jar of coins. If we have another jar of coins, we're going to have 5, 6, 7, 8 fourths used in 1, 2 jars of coins. Now we still have 4 fourths in each of these, so we are splitting our 11/4 into equal groups of 4. And then finally, if we continue counting, we'll have 9, 10, 11, and we won't need that last one. So we will end up with 2 jars of coins and 3 fourths of a jar remaining. And now we found this by using a picture by splitting it into fourths with the picture of the jars and finding how many we have left over. Now, if we want to do that without drawing the picture, as we mentioned, we're splitting those things into equal groups of 4 because that's what a fourth means. So we take 11 and we divide it by 4. Let me go ahead and move this fraction out of the way a little bit. So we have 11 and we're dividing it by 4. Well, 4 goes into 11 twice, with 3 left over. So this represents that we have 2 full jars that we can use with 3 leftover fourth parts. So in this case, we actually are going to look at a remainder. But to look at the remainder, we're going to say that there are 2 full parts. And then since each extra part represents a fourth, there are 3 fourths of that jar remaining. So when we divide it, numerator divided by denominator, like we talked about with the order of operations, we are going to use that remainder, but we are going to use that remainder as the fractional part of the mixed number. And so that process that I'll ask you to pause the video here and write it down is to divide the numerator by the denominator, like it says in the order of operations. So for an improper fraction, you're going to have larger number divided by smaller number, and you're going to write the answer at first with remainders, if there is one. We are not going to use decimals. And finally, we're going to change that remainder to a fraction with the remainder as the numerator and the original denominator as the denominator, simplifying if necessary, because that remainder represents the number of, in the last case, fourths that we have left over. So go ahead, pause the video now if you haven't already, and write down this process for changing improper fractions to mixed numbers. So if we look at this improper fraction, 22/3, and go through that process, we're going to divide 22 into equal sets of 3. We find that 3 goes into 22 7 times. Subtract 21. We have 1 left over. So we have 7 full groups of 3. So that's going to be our whole number. And we have 1 extra third remaining because our denominator is thirds. So our fraction is going to start off as thirds. So this conversion that we're looking for is 7 1/3. If you want to go ahead and verify that by drawing it as a picture, go ahead and do that now before we move on to the next kind of problems. So now go ahead and pause the video and work on these 3 problems converting these improper fractions to mixed numbers. So for the first one, 17/6, we need to divide numerator divided by denominator. So 17 divided by 6. 6 goes into 17 twice with a remainder of 5. That means for 17/6, we have 2 full sets of 6 and 5/6 remaining. So that is 2 and 5/6. For 25/9, we have 25, numerator, divided by 9. 9 goes into that twice, with a remainder of 7. That means we have 2 full sets of 9 and 7/9 remaining. So that means our mixed number is 2 and 7/9. And finally, for 37/10, numerator divided by denominator goes into 37 3 times, becomes a remainder of 7 again, 3 full sets of tenths, and 7/10 remaining for an answer of 3 and 7/10. So now let's look at it a little bit differently, trying to go backwards. Jacob wants to fill this pitcher of water, but can only do it with a 1/4 cup measuring cup. He's going to take a while to actually fill up this pitcher of water. The pitcher holds 5 3/4 cup of water. How can we find how many measuring cups he needs to carry or to use to fill this pitcher? Go ahead and pause the video, jot down a few thoughts that you might have, see what you can do with it, and come back when you're ready to talk about it. So if he wants to fill a pitcher that has 5 3/4 cups of water as its capacity, we need to figure out how many fourths is that. And to do that, we can convert this mixed number into an improper fraction by basically doing the process that we just went through to convert an improper fraction to a mixed number in reverse. First, we want to look at this 5. And this 5 as a whole number represents that we have 5 whole sets of fourths. Now, back from the other idea, we know that 1 whole represents 1, 2, 3, 4 fourths. A second one, 5, 6, 7, 8, would represent 8 fourths. And so to find the whole number, or the total number of fourths that we need, we take the number that's our whole number, and we multiply it by whatever our denominator is, because each of those 5 full cups of water represents 4 fourths. And so for 5, we have 20 fourths of water represented by those 5 cups. And then finally, when we have our 20, we have to remember that we have a fractional part to this mixed number, so it's not just 20 from the 5. There are 3 extra ones. So this represents 23 fourths of a cup of water. That means we need 23 1/4 cup measuring cups in order to fill the pitcher. And that brings us to the process that we use to convert a mixed number to an improper fraction. And the first step is multiply the whole number by the denominator, because each of those whole numbers represents 4 fourths, or 3/3, or 7/7, or 10/10, or basically a fraction where the numerator and denominator are the same. So if we have 7 as our whole number, and each 7 represents 3/3, then that 7 represents 21/3. Then we need to add the original numerator to that product, because we do have that extra that doesn't fill an entire whole number. We use that as the numerator and keep the original denominator, because we're going to convert, say, 7 2/3 into thirds, or 5 3/4 into fourths. So go ahead, pause the video, write this down, and then we'll go through a problem together and give you 3 to work on your own. So let's look at how that works with an example of something like 6 7/8. So each of those 6 for the whole number, 6 cups of water, or 6 feet, or whatever it is, represents 8/8 for each one. So in total, we have 6 times 8, or 48/8, which is what it means to have the whole number of 6. Onto those 48/8, we have this extra 7/8 that comes with our fraction. So we have 48 plus 7, or 55 total 8s. And that is 6 7/8 as an improper fraction. So go ahead and pause the video, work through these 3 mixed numbers, convert them to improper fractions, and come back when you are ready. All right, so for 4 2/5, that 4 represents 20/5. That's the same as it is for 4. Onto that 20, we have an extra 2, so 4 2/5 is the same as 22/5. For 7 3/10, 7 times 10 is 70, which indicates that 7 is the same as 70/10. We're going to add that 3 that we have left over from our fractional part on top of it and get 73/10 as our improper fraction. And finally, for 3 5/8, that 3 is the same as 24/8. Let me change that color there. 3 is the same as 24/8 because 3 times 8 is the same as 24. Now we're going to take that fractional part we have remaining. We have an extra 5/8 on top of that 24, which gives us 29/8 as our answer for 3 5/8. So, as a matter of quick review, to convert a mixed number to an improper fraction, I'm going to multiply the whole number by the denominator because that shows us how many thirds, fourths, sevenths, tenths, eighths the whole number represents. Add the original numerator because that's the extra that we had with the mixed number, and keep the original denominator and write those as a fraction, where if we are going to convert a mixed number to an improper fraction, we're just going to divide numerator into denominator, but keep the remainder because that remainder represents the number of extra parts from the original denominator. So the whole number that we get plus the remainder over the original denominator.